one of the most respected people in our field. So really honored to have him. Jonathan, why don't you come up, wherever you are.
Thanks, Jesse. I don't know about respect, but I'll take it. Thank you. So good morning. Welcome to Velocity Day 2. As Jesse said, I'm Jonathan Heiliger from Facebook. Talk a little bit about some of our challenges at scale and actually some of the oops moments that we've run into in the last 4 or 5 years. But first, let me at least talk a little bit about the mission of the company and why we're here. Our mission is pretty simple: to give people the power to share and make the world more open and connected. We think by giving people this power, this makes the world a more transparent place. And as a result, people end up having a fuller understanding and connection with all of the people around them and in their lives. So if we sort of apply this to the web, what this means is that we see the first version of the web was putting all the information out there that existed offline, now online. The next version of the web is about understanding all of the people who participate in it, the context of their information, and the context of their relationships. So let's look at a couple of the milestones we've had over the last 4 or 5 years of building the company. Started in 2004 in Mark Zuckerberg's dorm room and has grown from there. In 2006, we launched open registration, where we took the site from anyone with a .edu address to anyone on the internet could register and join the site. We also launched a feature called Newsfeed. Newsfeed was pretty interesting in that the first versions of Facebook were all about going to a person's profile, sort of one individual page. And if you had 10 friends or 100 friends, you had to look at 10 pages or 100 pages to see what was going on with all your friends. Well, with Newsfeed, we brought news from all around your network to one place on the site. And you could basically look at a sort of a newspaper or a magazine digest of everything that was happening within your network and within your friends. Within your group of friends. In 2008, we translated the site into 30-something languages. It's now up to 50-something languages. The reason I point this out is because we took a slightly different approach than conventional, where I think a conventional approach would have been hiring a translation house, maybe even bringing native language speakers in-house to do translations for us. And we've talked about this a lot, so I'm just going to kind of hit on it a little bit. But basically, a couple of our engineers wrote a translations framework. And the idea behind the translations framework was to harness the power of the Facebook community. And as a result, the site was translated in, as I said, 30 languages very quickly, including being translated into Spanish, which happened in 2 weeks, and more incredibly, being translated into French, which happened in only 24 hours, all as a result of the community using this framework. Facebook has grown pretty substantially over the last couple of years. And I think it also matches the increasing sort of pace of technology adoption, as we saw even at the beginning with the Conan clip, of how quickly we forget what life was once like without all this great technology. So today we're very pleased and humbled to have over 200 million active users, and we define an active user as someone who comes to the site at least once every 30 days. But as I said, this adoption has been accelerating. It took the radio 38 years to reach 50 million people. It took television 13 years to reach 50 million people. Computers reached 50 million people in only 4 years. And at Facebook, we did it in 3, which is pretty awesome. That being said, I'm sure there's people in this room that are going to do it faster than that. The pace of adoption continues to accelerate, and it's proven every day to us. If we even look at how quickly we've grown recently, the first 100 million users of our 200 million took 4 years to come to the site. The second 100 million came to the site in only 9 months. So incredible and accelerating growth. So now I want to talk a little bit about sort of how we deal with these growth challenges and how we think about them. In general, we prefer to solve problems through clever engineering. We relentlessly look at how we can avoid failure. And even with that, we fail all the time, and we're pretty happy to fail all the time. We really view people and process as secondary to really, as I said, to really clever engineering. So I want to talk a little bit about maybe what my day was like at work or what your day could be like at work. This is kind of a classic battle of operations versus engineering. Ops wants to do nothing to the site, right? We don't want to change things. We want to be conservative. We want to hold the line. We don't want anyone coming in messing around in our sandbox. Engineering, on the other hand, well, guess what their motivation is? Their motivation is to develop things, to try new things, to break things. Well, maybe not break things, but at least try new features. They're being driven by the business. They're being driven by users. So how do you balance this tide? Well, what usually happens is you get conflict, and I've had the pleasure of working in a lot of really great companies, and I think at pretty much every one there's a fair amount of conflict that ends up happening between engineering and ops. But I'd ask the question, is this really how you want to behave? Is anyone actually forcing us to fight, or is there a better way of working together? And it's not to say that we shouldn't challenge one another in terms of operations challenging the need to actually make changes all the time, or built in hardware redundancy when you could develop software redundancy. I'm not saying avoid that kind of conflict, but I am talking about how do you avoid the conflict that's just not constructive, that's just kind of friction for friction's sake. Well, one way you do it is you practice. And you can't just go from sort of doing this battle every day to winning as a team and really working together as a team. It takes a fair amount of iteration, and something we do a lot at Facebook. And I think the thought process I just wanted to share is, first, it's about having an individual sort of working towards their goals and succeeding. And as individuals practice, they hone their skills, and then as a result, they can become a team, and they can really work together. But that being said, it's not without fault. It's not without danger. Some of the greatest athletes in the world have had epic failures. And getting back up again, trying again, breaking things again, in my view, is what makes them great. So as I said, at Facebook, we fail all the time. Our goal is to make it transparent to our users and safe for our employees to fail. At the end of the day, the sum of all these individuals working together is greater than the individual parts. So here's just the fun little jube shot, right? As a team, we can all come together, score a goal, win, keep the site up. It ends up being a lot about personal pride, and the opposite of pride, embarrassment. No one wants to be the guy who took down the site, but conversely, it can also be a proud moment to say, well, I showed up for Facebook, showed up to work at Facebook. You know, first week on the job, I pushed some code, I took down the site. That's a pretty proud moment as well. So I've talked a little bit about just sort of the dynamic, and you can kind of guess where I'm going, which is it's kind of all about people, in my view. And everyone hires the best people. That's pretty simple, right? No one wants to hire the bottom of the class from Harvard or UCSF or wherever. And people ultimately build technology. But people should be building technology for other people, not for the sake of building technology. And if these people are organized, as these people are organized and motivated, in my view, is what can make the difference between having your day be fraught with conflict or a relatively warm, fuzzy, cozy place to work where you can get a lot of stuff done. So now I'm going to take a look at sort of how we're organized at Facebook. So called it the operating pipeline. Couldn't really think of a better name. But basically, sort of classic, I think, how most companies end up building their technical organizations. We didn't do this for a reason. So first and foremost, right, engineering develops code. You then hand it off to QA. QA gets to test the code, and sometimes they kick it back to engineering. They yell, they kick, they scream. They figure out problems. And then operations is responsible for deploying it, for scaling it, for making it work, and kind of fixing all the cruft that those QA guys forgot about or the engineers didn't get to work right. Well, as I said, at Facebook, we didn't do it this way. So we don't actually have QA. Every engineer is responsible for writing their own test cases. Note I said responsible. I didn't say do all the time. But they're responsible for it. And ultimately, they're responsible for the efficacy of their code and the reliability of their code as it goes live. So at Facebook, it's about... At Facebook, every engineer is responsible for for the cradle-to-grave lifecycle of their application, of their code. Instead of handing it off and having a breakpoint or a firewall or some kind of, a hop, basically a chance to lay blame or a chance to have an excuse or a breakdown or anything in the process, that doesn't happen. Instead, an engineer shows up, they write some code, hopefully they write some unit tests, hopefully they test it, they can even peer review it and check it with their friends and their peers, And in some cases, they can collude and say, oh, no, I signed off on that. That's all good. Didn't really. And then they push it live. But when they push it live, that's when operations gets involved. And so we do it in that we help with providing some guardrails. And the guardrails are there to basically ensure that we don't hurt ourselves too badly, to actually ensure that we don't take the site down. Maybe we take a feature down or a component or potentially degrade service for a little while. But it doesn't impact users, as I said. And we came up with this, and it's still very much a work in progress. It's by no means perfect. We came up with this. I did kind of the typical executive thing when I showed up to Facebook about 2 years ago. I sat down and I interviewed some ops people, and I said, hey, what's working and what's not? I sat down and I talked to a bunch of people in engineering. Same questions. What's working? What's not? And unsurprisingly, operations said Eng is way too unstructured. They don't know what they're doing. They don't plan. They're just kind of throwing shit over the wall, and we don't know when it's coming. We don't know why it's coming. We don't know how it's going to come. Engineering said, oh, those ops guys, they don't react well. They're not nimble. They don't know what they're doing. So instead of just kind of feeding the fire, we just said, you know what, let's just make it a combined problem, right? Let's get these groups to work together. Let's have engineering own the problem from cradle to grave, from beginning of sort of idea conception all the way to the live site. The really interesting thing, I think, is there's lots of interesting knock-on effects of doing this. We built a whole tool set around this pipeline, around continuous build, around code review, around peer review, around performance testing. And that suite of tools is what's allowing us to move really quickly and continue to grow and scale as we've gone from 40 people in engineering to 200 plus people in engineering. So this is just kind of another view of the same type of thing. It's our perfect organization. And by perfect, it's never perfect. Trust me. But it's a pretty simple axiom, which is we want to put engineering as close to the customer as possible. So engineers don't get to hand things off. They don't get to say, oh, someone else thought of that. That's not my problem. I don't know what's going on. So, as I said, pretty simple. We put engineers in ops and ops in engineering. We'll explain what this means. So in terms of putting engineers in operations, we formed a site reliability team who pretty simply is responsible for keeping the site reliable. They're the stewards of the site. They get to decide whether or not something should go or not go. They decide to add capacity, remove capacity, basically managing the site and responsible, as I said, for being the stewards of the site, in addition to running core services, mail, DNS, et cetera. Then we have an operations engineering group. They're responsible for all the systems that help us scale, so provisioning systems, monitoring, alerting, all of the tooling and all the glue that pulls together our actual applications. And then we've embedded operations into engineering teams. So we have a consulting engineering group that basically goes around and partners with every back-end service group. Because it turns out guys with CS degrees are awesome programmers, not so awesome at hardware or scaling or thinking about redundancy or the things that come with, quite frankly, apprenticing in the business of operations. And over time, those guys with CS degrees learn, but it takes some amount of time. So the consulting engineers, they help with design, they help with fault tolerance, system sizing, et cetera. And then, as I said, since we have this notion that engineers have cradle-to-grave responsibility for all our applications, our software infrastructure is owned by a team that's responsible for maintaining MySQL, Memcache, Apache PHP, et cetera. They're on call. So if we need something tuned, if we run into a bug, if we run into a problem, a memory leak, God forbid that never happens on Apache, they're there. And they're on IRC, they're participating in it. There's no long, drawn-out process of, hey, how do I get these people involved to help me solve my problem? So next is just a pretty simple picture. Let's just put this into practice. This is a photo from our war room of our username launch a couple of weeks ago. This was Friday night at about 8 o'clock at night. And you can see there's lots of people from many different areas all across the technology team coming together. Had people from SRE, the developers themselves, product managers, probably 40 people in total. We even had our international PM in there just kind of hanging out eating Chinese food. He just wanted to be a part of the process, wanted to just see this new thing go live. So switching gears a little bit, I'm going to give you a couple different examples of how we have applied this and some of the lessons we've learned in terms of both succeeding and failing at getting it done or not getting it done. Like many other things, You can have a really elegant, really scalable solution in mind. But unless you can execute really quickly, really effectively as a team, the sophistication doesn't matter. Throw it all away. Doesn't matter. Like with a lot of things I'm talking about today, I think it's a pretty obvious point, which is design is awesome, but it needs execution to actually succeed. I'm going to talk about, or I'm going to give you 3 examples of things we actually did that we thought were going to break the site every time. And we did them in such a way that we could control them, that we could test them, some with our users and some in our own lab. But we did it this way, and we did it live for a really specific reason, which is we wanted to watch how the organization responded. And we wanted to see how people would react and who would step up. And because, quite frankly, I believe, and this is something Jesse and I have talked a lot about, if you can fix the actual problem with real motivation in a real live situation, there's so much more to it. There's so much more pride, there's so much more challenge that comes with that versus I ran a test. I think this could happen. Or that engineer over there, that QA guy over there says he thinks this could break. Instead, why not test it live? So let's look at a couple of these examples. The first one I'm going to talk about is the CNN live feed. This idea was conceived over the Christmas holiday before Barack Obama's inauguration. In a couple of weeks, basically like a week after that, a group of, 20 people or something like that came together, PR, marketing, engineering, ops, a whole bunch of people came together, said, we have this great idea. Let's do a CNN live feed, bringing together the richness and all the visual aspects of video from CNN and all the commenting and perspective of your friends and even people around the world. We knew this would be big, and as a result, planned accordingly, added a bunch of capacity, had a war room, etc. But it all happened pretty quickly. The whole program, the whole framework, if you will, where you could take a live video feed, combine it with friends commenting, was written in about 3 weeks entirely from scratch. It's since been replicated and reused to handle events like the Oscars and the NBA Finals. But with the inauguration in particular, we knew there was going to be a point load, condensed usage. Kind of sounds like a DOS attack. But careful planning, testing, added capacity, hopefully avoided disaster. One of the things we did first and foremost was put levers in place to be able to throttle traffic up and down, features up and down on the site, so that if we ran into contention or some kind of weird situation, we could slow the refresh rate down, for example. We could turn off chat, or we could reduce the number of thumbnails or images that loaded on the site. All really minor tweaks to the user experience, but ones that would give us the headroom to be able to perform should we need them. So let's just sort of look at this, and I can kind of see where the video's at, but there's basically 2 tabs. There's one tab that shows status updates from your friends, and there's another that shows status updates from everyone. It's kind of a global view, if you will. So 2 different request types. Friends you had to generate on the fly, right? Because you had to actually go and cull your friends list and find the most 30 recent status updates and bring those out of Memcache and present them to the user. And everyone, pretty easy to cache, right? It's global, publicly readable, so you could cache it. We actually used a CDN, not surprisingly, to help cache it. One of the interesting things, though, that we didn't anticipate was the delay that a CDN added. All of a sudden, you had this tree of nodes and tree of caches that all had to be clock synced, because any delay would mean the user would get a blank page. And that was that was just an unexpected side effect of the design we'd put in place. But what we didn't actually expect was that users would sort of act like maniacal channel switchers and click on both of these tabs back and forth all the time. 1 second they'd be looking at everyone, the next second they'd be looking at their friends, the next second they'd be looking at everyone, the next second they'd be looking at their friends. Well, you can guess what happened. We had a set of objects that were globally cached, had a little synchronization problem, generally able to get around that. But what we had were people just pounding the crap out of their friends' status updates and really context switching back and forth, not even just sort of resting on one or resting on the other. So, lesson learned. Cache everything, even if it seems unlikely. So through this program, or through the inauguration, in the first minute there were 8,500 status updates, just to kind of put the volume in context. And by the end of the day, over 2 million status updates happened in a pretty short period of time. It ended up becoming the biggest live streaming event ever on the internet. And the thing that gave us the confidence to do this was we were able to dark launch the site before it actually went live to users. Dark launch in our world means we were able to launch the site, launch all of the backend, exercise the feed components that also power the homepage on the site, exercise status updates, et cetera, without actually having a front-facing user interface on it. So we had, for a couple of weeks, millions of users exercising all of the stack, all that logic, without actually seeing what was going on. And by virtue of not seeing what's going on, they didn't see the actual sort of user interface, but they were participating in the test. That was all just done through some JS calls on everyone's homepage. The other thing we did is we built a little performance framework into that to measure what real client experience would be like rather than depending on data from third-party measurement sites. So we used sort of both of those data sets to be able to size the system. And as a result, at the time, in February when the inauguration happened, it was a new peak traffic day for us. We've since surpassed it, but at the time, it was a pretty good moment. So next, I want to look at a feature we launched earlier this year called Like. Like is pretty simple. It's kind of akin to clapping for a comedian at a show. It's just lightweight commentary of, yeah, I like this. So you see on my wall here, I posted a photo, and two of my friends like it. Pretty simple feature. We actually didn't think that many users were going to use it right away. Unfortunately, we were really wrong. You guys can read the data. The point is, we launched what we thought was a pretty simple feature. It had a fairly interesting effect on a read-to-write ratio on the site. Facebook.com is a very heavy read environment, so it didn't numerically shift the numbers, but from a just raw traffic perspective, had an interesting effect on both Memcache and our backing stores to that. And you can see, within the first month, 250 million likes were logged. That's 250 million new writes we didn't have the previous month. Completely unanticipated. The last example I'm going to give is our username allocation, which happened a couple of weeks ago. So usernames are, facebook.com/jh or facebook.com/default.aspx, whatever your personal favorite username is. And we decided to allocate usernames. Initially we were going to actually run an auction process. And the idea was you'd come and bid and do something kind of wacky and crazy. So we came up with a code name. The code name was Hammer. Kind of like an auctioneer's gavel kind of thing. Well, we went through the process, decided auction wasn't the right way to go. Instead, we'd go first come, first serve. We kept the code name Hammer. I thought it was pretty appropriate because we were about to hammer the crap out of our site. And that's pretty much what happened. Again, we were able to load test this for a couple of weeks prior to actually launching it. That illuminated several unknown issues, particularly around kind of system dependencies and other things in the site. So we delayed the launch until we felt really comfortable. Another kind of interesting side effect, as I kind of alluded to, is we had to have a blocked list of trademarks so that people couldn't actually register them, and we missed a couple. These were kind of some of the funny ones. Jack Bauer could whoop Chuck Norris's ass, or someone does own facebook.com/default.aspx, so we are forever blocked from running ASP.NET in our architecture. It's a problem. It's a real problem. All right. Here's just simple graph of a load test. As you can see, we'd like to hammer our site. We did this. The time was late at night, so it was well below our peak hour, but well above what normal traffic was at that point in time. It illuminated, as I said, some odd system dependencies. We delayed the launch, went forward. Then we actually launched. So the graph that's on your left, if I'm looking at this right, is the instantaneous kind of point load to basically a segmented cache pool that just contained all the username data. So you can see right at 9 o'clock, that's when we launched. Tens of thousands of requests came in for people to allocate their name and reserve their name, but no change in latency, which is the graph on the right. So from that perspective, we actually over-provisioned capacity. We had a couple of spare servers sitting idly by, et cetera, should we actually have any hardware failures or anything happen during the launch. And then just going back to the left graph for a second, you can see kind of usage trails off over the night, over the course of the night. We didn't get the expected bump of users we initially anticipated we would get. And there's probably a couple reasons for that. One, we made the page as lightweight as possible. So we didn't really stress the system. And in fact, This is a graph of the actual launch as it happened. And such a blip in terms of aggregate capacity and aggregate system load. I actually had a little circle it just to point it out for everyone here to see today. As I said, we didn't stress the system as much as we anticipated, probably because we made the page super light. We turned off all the unnecessary features like chat. Images were totally turned down. The amount of JavaScript, which we've gotten continuously heckled for in our site, was stripped on that particular page. And we picked a pretty odd time to do it. Friday night at 9 o'clock, 6 a.m. European time. Not a lot of users on the internet at that time. Intentionally so, because it was when we had some extra capacity. So just a testament to, I think, good engineering and testing and planning. So as a result, 200,000 usernames allocated in the first 3 minutes, 500,000 in the first 15, and over 1 million in the first hour. And as of today, there's over 12 million usernames that have been allocated. No other changes to the site happen, no code changes, no other crazy load balancing schemes had to happen in order to support this. So to me, this is just a great example of how the organization responds to dealing with a potential problem. Then we'll shift gears one last time, talk a little bit about bad data center cabling. Everyone's got a data center like this. In fact, we still have a data center like this. It's small and contained, thankfully. And to me, the message here, and this is a little bit of a departure from what I've been talking about in terms of people and how you approach teams and team building and working together, but it's also something we very much embody and believe in and talk a lot about at Facebook, which is be frugal, but spend where necessary. And one of the reasons we think we've been able to handle launches like the inauguration, like usernames, et cetera, is we've invested pretty significantly in our infrastructure. And so as a result, we can scale. It's pretty easy to grow. But like software, it takes a lot of iteration. So the previous graphic was actually data center number 2, not data center number 1, but data center number 2. This is data center number 3 or 4. And we've probably we actually have subsequent designs and subsequent versions today. Data centers and infrastructure end up being the second largest expense in a web business after people. Both very important to get to run properly and to invest properly in both. I don't think we're cheap, but yet our vendors kind of complain and gripe and say that we push hard bargains and we're kind of hard negotiators and tough guys to deal with. But again, the message here is invest where appropriate and just don't be cheap. That can be on your own back. You can build the site yourself. You can build out data centers and servers. Heck, you can even go buy CPUs and motherboards and put servers together if you really want to. Or it could be somewhere in the cloud. You could use S3 or EC2 or any of those other cloud-based services. So just wrapping up, highlight the 3 launches that I talked a little bit about. One, the CNN inauguration, the President Barack Obama's inauguration, anticipated load, we're able to plan for it, had a pretty radical effect on our site, new high traffic day. Completely unplanned, unanticipated, yet we still survived through it. And the third, usernames, anticipated launch, anticipated point load, but fairly low stress on the infrastructure because of how we timed it and how we designed it. So just recapping the things I talked about before, we believe that the most effective technical organizations are ones that can move fast because they can iterate quickly and test quickly. And you do that through collaboration. You do that through distributing accountability to every engineer and not holding it up tight and close in a manager or director or, God forbid, a VP. And really test with users. Don't test in the dark. All that being said, one last final thought to leave with you guys today, which is the great Vince Lombardi said it best. The only place success comes before work is in the dictionary. If I had to give this talk a year from now, I can guarantee you our organization wouldn't be structured the same way. Definitely not at the end of the road, not a perfect solution, continuing to iterate both on technology, on infrastructure, and on how we're organized. I hope this was interesting and useful. Thanks for your time.